Alright guys, let's finish this sucker.
Me too.
I must consume Triple X. What about the movie Triple X?
Hey! Hey! Let's finish this worksheet up.
Did you say and go home? Is that what someone just said?
You can go home anytime you want to. It's college. Be dumb and not come. Or leave early. Completely up to you. I don't care. Alright. I don't care. So in this first part A, why don't we need to be told it's normally distributed?
Because there's 38.
Yeah, I like it. The sample size is 38, which is above.
30.
What's the magic number?
30.
More than 30. I like it.
Isn't that what it said?
To be honest, I don't know if I ever wrote this down, but it's the theorem that we use is called the central limit theorem.
Central? That's on the right on the test. Central limit theorem.
CLT.
It's on the right on the test. CLT.
Right? You can let us know. Central limit theorem is the one that says the mean stays the same, but the standard deviation changes, and it's also the one that says the greater than 30 things. Okay. But all you got to say really is, if I say it takes 57 things, and like, why is it normally just say because n is greater than 30? But just to let you know, it's called the central limit theorem. Cult. Yes, the CLT. All right, how are we doing so far? Why on the first one did I have to say it was normally distributed? I had to. If I didn't say it, we couldn't do part of this problem. Why?
Because we were picking individual values?
Yes, I picked one person. Right? Not a sample of anybody. I have to know it's normally distributed in order to be able to do that. Here, I picked 38 people. I don't care what the population starts off as. Normally distributed, not. I don't care. 38 means will come out to be, or 38, a group of 38, the means will come out to be normally distributed. Enough, anyway. So now I can do part B. But before I do part B, what's the very first thing I should do?
Standard deviation.
Good. The standard deviation they gave me was for individual apartments. I need to find the one that's good for groups of 38. So I change the old one, which is 296.64 divided by
Square root of 38.
square root of 38. I like it. This will make the standard deviation that's good for groups of 38. This does not make it into a sample standard deviation. If I knew S, I would still have to figure out S sub x bar. I'd still have to do this. It's because it's the standard deviation given is for individuals. I need the one that works for groups, in this case of size 38. When you do this, what do you get?
48.12.
Who is it?
48.12.
48.121.
121.
And now I can draw. You guys like going? I can draw the picture. What goes in the middle? 2702. I want the probability that it's below 2650. So now I can make a z-score out of this.
0.7.
What do you get?
I gave how much?
Negative 1.08. Sounds familiar. Is everybody with me here? Is everybody? If it's a no, you've got to have a question in there somewhere.
Thank you.
How'd you get to 296?
Oh, he gave me one. Thank you.
You see it? Yeah. So it's a really good idea. I know I'm not doing this, but I probably should just to help you guys out. You should find every number given in the setup and give it a symbol. So 2702 would be mu, and 296.64 would be sigma. Yes? How did they get 30? From the idea. What's the theorem say that we talked about earlier? The magic number is the
30.
sample size has got to be above 30.
30, 40, and 30.
The sample size is 38. That is bigger than 30. Therefore, if I plot out all the means, they will be normal enough.
If it's the question that just
That's
says
the
why,
idea.
how do we not need to do 12? Because remember,
So did it come from this problem at all? Did 30 come from this problem? No, it came from the idea. If I have a large enough sample, then it will end up being normally distributed. That's an idea. Like,
It's the CLT. That's what that theorem says.
central limit theorem.
CLT chicken.
So the mean stays the same, the standard deviation changes,
Let's be real.
and n's got to be greater than 30.
Social limit theorem.
All right, guys? Yes? Well, we're not done. Oh, sorry. About 30? Yeah.
But if it's over, like, what if it's like 30? What if it's like 500? Is that normal?
All right. Just because somebody else didn't hear before doesn't mean it's something I didn't say. Everybody here understands, most everybody, you remember last time and today, n greater than 30 guarantees that if I plot the means, it will be normal enough for every possible shaped population. So I had an ugly population up here earlier.
9,000.
As long as n is greater than 30, it becomes normal enough. That's just part of the theorem. And to be honest, the way they did it was they plugged every kind of idea of a population they could into a computer and said, computer, take samples of size 10, take samples of size 15, take samples of size... And they saw at 30, most of them came out to be normal enough.
So if it's already normally distributed?
Yeah. If it starts off normal, how big of a sample do I need? 1. That's why I was able to do 1A. It was already normal. I don't need a sample size bigger than 30 to save my ass because it's already normal.
So no matter what sample size, it's normally distributed, you can just work
Yeah,
with whatever sample
totally.
size.
Yeah. In fact, that's how I did this one.
Yeah.
11 fish. 11's not bigger than 30. So why were we able to do this problem? Because it was already normally distributed. Yes?
On the test, if you ask a question like that, is that answer like good enough or?
Yeah, that first piece. N equal 38 greater than 30. You.
I'm just going to put CLT.
As long as the sample you pick, the samples you pick are greater than 30, they'll result in a normally enough distribution. That's the whole idea.
Got it.
And again, why is that so important? Because I can make z-scores anytime I want to. Well, it's the only time I can change them into percentages at the moment is if it's normally distributed. That's the only time I can use that chart. Yes?
For B.
We're not done with B. Right.
Oh,
Someday we'll be done.
we have to find the area, right?
Bigger than 30.
What if it's 30?
Oh well, too bad. What if it's 29? Oh well, too bad.
Like in C, it's 18, it's still normal distribution to get it.
So why was C okay? Why did C not matter? Just like I just said about 11 fish. Why is the fact that this is only 18, why is it okay? Because the population started off normally distributed. Then I could do it with 1, I could do it with 2. Doesn't matter.
But like if it's 30 to be exact, then you got okay or not?
So I can't be the only one that's going a little insane. What's it say? Yes, so it's 30 above 30.
No.
Okay. You just answered your question, right? Hopefully. All right. How to stay with me, guys. I love it. Now, what's the last step with this problem here?
Fine.
Look it up in the chart.
Look at the chart. So negative 1.08.
Dang, dude. Put
Yeah,
401.
1401.
I got excited. I'm sorry.
Avi.
I like it. Let me give you guys the answer key for that practice.
Yeah, so
When they make formula sheets,
We should all just do the practice test we learned sometimes.
I'm gonna do the practice test tomorrow morning before I come to class, so it's all fresh in my face. That's what I did last time. I got a 90 on my test.
probability?
No, not that one.
Last test.
The last test. Yeah. And I just did it right before because
Testing. Thank goodness.
I can't breathe today.
Are you dying? Well, at least you have responsibilities.
And this is hot. It's right here. And right here. And my back.
You should look it up on WebMD. Look up on WebMD.
MD. NYMD. WMD. Yeah. I got 36 hours strength.
Everything is cancer. Everything is just cancer.
Yeah, I mean, I could have,
I
but
have a cough.
WebMD, I just watched the 53
You have
cancer.
Oh, the blank?
Freaking WebMD.
I think so.
What happens? I come out I'm okay. Cancer.
No.
WebMD, man, like,
No.
I'm missing going
I gave them all away, dude. So somebody must have taken an extra copy that didn't really need it.
I just feel like
All right, guys, let's make formula sheets.
WebMD, I just cut it off. You need to cut the other one off.
You're good.
The most important thing is balance.
WebMD.
I love WebMD.
I have a headache. You have cancer.
You have cancer. You have cancer.
Look at everything up with WebMD.
Want to finish problem B?
What? D.
What?
You want to finish problem B?
I did. 0.1401 right there.
Oh.
I don't know. All right.
Honestly. Is this a mush?
All right, guys, so if all your formula sheets before now, if you didn't lose points on any of them, you can just bring them all in with you
Yeah.
and add these in. Francisco. All right, so let's talk about some formulas we could use. Yes, Z-score is a good one to start off with. What's the only difference between those two formulas?
One's a sample.
Yeah, one's for sample, one's for population. They're not really different. Your data point minus the middle divided by the spread.
Yeah. X equals.
Which one's for population? Do not dare put POP next to it or something. You're not allowed to have little words or notes or anything.
We
You
can
just
put
got to
them
know that. That's why I made a big deal out of the fact that Greek letters
page.
indicate population very often.
We have
Sorry.
to put them on opposite sides of the page.
What's the matter? What's happening? Finish the question. Say again?
Yeah.
That's right. Go ahead.
Z is always Z score.
What? I don't understand. All right, guys. This is really freaking me out today. These are both. Hey, guys, shut the hell up. These are both Z-score formulas. They're both the same formula, to be honest, right?
Yeah.
But why do I write them both down? Just in case I give you X bar and S. How do you make a Z-score? Data point minus the middle divided by the spread. So these are the symbols. If I give you symbols like that, it's a population. These are the symbols for a sample. Right?
Sounds good.
Greek letters, like I said, first, second day, population. Our letters, just a poor little sample. Right? Greek letters to make it all like, whoa, it's everybody. Yes?
So that's just an S.
Yes, that's an S. Yes. Say again?
It stands for sample.
Definitely not. What's that stand for? Standard deviation of a
Of a
sample.
sample.
But S doesn't stand for sample.
No. That's for
This little weird fat R dude is sigma. That means population standard deviation. S, as we've known for a long time now, means sample standard deviation. Okay, yes?
So when someone's normally distributed, in both everything where it has saying the median and the mean will be the same. If it's normally distributed, is that also true of the mode? Like all are basically anything used to find the middle. If it's normally distributed, will always be the same value.
Just throw it on there.
If it's perfectly normal. If it's approximately normal, it could be off, but they should be really close. Okay. I didn't realize I'll get so much controversy already. It shouldn't have been. It should not have happened, but it did. So we're past that. We're over it. We understand everything so far. Good.
Are we?
Better be. So this is always true how to calculate a z-score. What else do we have? We really don't have that many formulas that we've added, to be honest. Now I did admit I did pass up. We do have this on this test.
Yeah.
This stuff here, right? I'm gonna kind of gather this stuff up. Oh yes. Some of you guys wish it wasn't true.
That's the only thing
Why did I get weird looks for that one? You guys all right?
That's the only thing I get.
Oh my God! Some of you guys are like, have we done that? Oh, some bad shit. Remember, if I give you x, p of x, then you multiply x, p of x, and add them up to get the mean. Okay. So when do I use this? Well, probably when I give you x and p of x, right? And then the standard deviation. Just reading your mind as to what questions you may have. The most common mistake on this, there's two things. There's something that happens that you should be past by now. You try to plug stuff in. No, that doesn't mean shit. This whole thing is going to be the sum of one of your columns, right? You replace that whole thing with a number. The second mistake is a small one, is you forget to square that poor little dude. Right? It's minus the mean squared.
Everything is square rooted.
Yeah. Yeah. You could write.
Can you write the variance?
Sure. What's the variance one? How's it different? Instead of a square root on that side, it'll be squared on the other side. So if you really want to, I have no problem with that. If you don't want to, then don't.
What's that?
And we also have the binomial stuff on here, right? Okay. So you got that stuff, right? Binomial.
That's the one you just plug in your numbers.
Yep. That's how every formula works. You just got to know when to use the right formula, right? That's the key to statistics. When do I use which formula? When does it change a little bit? That's what really is involved, yes?
The C in the formula, that, like, nothing is plugged in there, that's just like...
That just means choose.
Oh, choose.
This little piece in front by itself is just how long the list would be.
And so on the test, since we can do it on our calculator, do you want us to write it out like that?
I need to see it written down, yes. And then you plug it in the
Do we need
calculator.
this formula?
That would be showing me your work.
Mu equals n times p.
This is a probability question, right? The probability I get so many successes.
Yeah.
Then I can ask you, well, what's the average number of successes? And that's a beautiful little equation.
And p standard deviation is square root of n times p. No.
Sorry.
Second one.
What's happening?
Square root.
Sigma, the standard deviation is the square root of np cubed. Okay, all right. Oh, God help me. So you can go back to your handouts.
That's for sure.
Jeff has given you a handout. Basically, every formula we've done is represented on some handout at least once, with example of how it works, method to my madness, trying to help you guys out. Yes. Yes, this is the mean. All right. This is binomial situation. So that would be the average number of successes. If I make 60% of my free throws and I shoot 20 of them, that should
These are
be the
all
average
three
number of
different
shots I should make.
Right?
All right.
1, 2, 3.
The standard
I
deviation
mean, you can even like go like this. So just
of
gotta.
all samples. What
Huh?
we just did was
What's happening?
You high?
standard deviation over square root of m.
Okay. All right. So I had to go back and get chapter 4 up here. Chapter 5 is the uniform distribution stuff. I'm not going to worry about uniform mean and standard deviation, all that kind of shit. You did that in the homework, or else I'm going to make you do it if you didn't do it. Right, so there's chapter 4. Chapter 5 is just ideas, really, of uniform distributions. Yes, ma'am?
The side, how about the x equals?
Yes, okay. Now, let's come back. This is chapter 6 and 7. So we got this backwards formula we used today. When I say backwards, I just mean this is what we normally think of, and this is just that written solve for x instead. And then you've got this idea.
Oh, yeah. I'm laughing at people now, but
Yes.
I was laughing at myself after this test.
So x is mu plus z sigma. Say again?
You could find me in algebra.
Yes, z sigma. Yes.
Mu equal. What is mu equal?
Because again, when you do the algebra up here, don't I multiply sigma up?
Z times sigma.
So the one you just wrote right there, isn't that just for proof? Like what we just did for 2A?
Yes. What's 2b? Yeah. Change the standard deviation? Yes.
What do you look like in me?
Yes, with me. Now, please, through God, again. You can't put little notes. Can't put, use this when. You can't put little marks that could be notes in your own language, right? And sometimes that's your own language you made up, or your own language that was your first language, right? So if I see little symbols that might be Arabic or Chinese or something, no, you're not allowed English notes or notes in any other language.
Just math.
Currently existing or something that you made up yourself? Yes.
Mathish.
What about lines like this?
Yeah, lines are fine. You can separate ideas like that. It's a smart way to do it.
Gucci gang. Alright, let's see what else.
They're going to develop a line-based language, I like. Well, at least, in that case, at least you're doing something.
Isn't it Norse?
Yes.
Oh, do we need this?
Oh, yeah.
Yeah. As long as you don't want to bring in formula sheets that you lost points on.
Okay, so we can bring it.
But you could bring in everything you've done so far and then add another formula sheet. This one. Yeah, that's great. The final, you can just bring a big stack of formula sheets. I don't care.
Hell
Yeah, like I said,
Last chapter found, yeah.
there won't be,
Oh,
there
that's
will
true.
be uniform probability problems. I will ask you to draw them out. I'll ask you to put the height down. I'll ask you probability questions.
But you
I'm
don't
just
have
not going to ask you to calculate the mean and the standard deviation, okay?
Okay.
I just wanted you, again, like I said before, I want you to know they exist. I want you to know they act just like any other mean and standard deviation.
The fucking things right here.
They get around those freaking things. Yes?
For the formula sheet, if we got a dog's point, we can't correct that, right?
No. That's why it sucks. Don't do that. You're giving yourself an unfair advantage. Yes?
So with the homework, it's due all homework at the end, or like the correct homework?
How much did you know?
Homework is due by the day of the test, and if I ask you to make corrections to it, that's due by the day of the final. Yeah, because I want you to keep up with new homework primarily. Final's cumulative, so if you get extra practice towards the final, it's great. So I'll let you do that later. Yes? You're good. If you turn in all your homework on the day of the review or the day of the test, and you do well on the test, then you don't need as much help from me. I'm going to devote my time to the people that either turn it in early so I can get it back to them on the review day, and that's happened for a lot of you guys, because then you can use it as notes to study for the test. Or, if you made a really low grade on the test or below average grade, I'll grade your homework first to get it back to you. So if you end up getting like really high grades on all the tests and you turn your homework in on the day of the test all the time, you might get it all back from me, not even looked at. just the way it is. You guys look around. You guys see how many people are in here right now?
Like 12.
So I'm going to focus my attention on those people that need my help, right? If you're doing really well on the tests, then you obviously don't need my help as much. Because that doesn't make sense. It's too bad. Over there? Okay.
Something's wrong with you.
All
Gosh
right,
dang it,
cool.
where did I put the
Anything
answer
else? Any other formulas I forgot?
sheet? Is this the answer sheet?
Anything else I
Except one
forgot?
answer sheet.
Okay.
Michelle Marie,
So now
thank
it's
you.
wide open to whatever you want to look at. You can look at the practice test,
Oh, time for some homework.
homework questions. Remember, this goes back to chapter 4. 4, 5, 6, 7 sounds like a lot, but each one had like 2 sections in it.
Shut up, it was. Not a lot of work. No, because you did
Sure,
all-
you can. I'm just not going to ask you a question about that. So that's what I just said. The uniform
Because you did every one
I know.
every fourth one.
sure is. Yep. In the homework you saw that kind of stuff? Totally.
Totally.
Not on the test. Yeah. Okay. Yes.
Maybe
All right, guys. I got a question from homework 19 in chapter 6.
Are you leaving, bro?
Oh. All right. So this is formula sheet. This is answering a question from homework. So hopefully you've gotten used to the book's weird little way of notating things about, like, they use this notation. You could put a B here, or a U here, or an N, nice little bun. Binomial, uniform, normal. Okay? So when they say, in number 19, they say X is normally distributed, where'd it go?
What?
4, 2.
6.1.
Doesn't matter, it's number 19. Have you guys gotten used to that yet? Turn it in by sections, but just go by numbers when you do the damn things, right? Okay.
We didn't have to do number 19.
I don't care. This is the question.
Okay.
So what's it mean? What's this mean here?
The median and standard.
The mean and the standard deviation. I like it. So for B, for binomial, it's going to be NP, because that's the most important things to know. For uniform, it's going to be AB. Where does it start? Where's it end? And for normal, it makes sense. It's going to be mean and standard deviation. All right, so that's number 19. Tells you this, which you interpret to mean this. And then they ask you, what data value is 1.5 standard deviations to the left of the mean? Is that cool? You guys see that?
Yep.
So what data value is 1.5 standard deviations below the mean, to the left of the mean? What is this 1.5? The z-score. Can't be an area because that's 150%. That's crazy. This, why is it a z-score? Because the z-score is the number of standard deviations from the mean to the data point. So they're telling you z is negative 1.5. And they want to know what the x, what's x. So then you can just use that formula here. You don't even have to use a formula, to be honest. If you start at 4 and you go down 1.5 steps, you start at 4, go down 1.5 steps. But that is the formula, isn't it? The mean is 4, z is negative 1.5, and sigma is 2. So why is it the formula? Because that's the idea. Formulas capture ideas. So whatever the hell that is. Yeah, 4 minus 3. I like it. I actually asked you this kind of question on test number 1. Because I actually gave you this kind of idea back in section 2.7. You're kind of reminding us of it here now. Okay. Anything else from homework, practice test stuff? Yes. Which part? 50? 58? Oh. Between 2.8 and 6 years, it looks like. So they just ask you to fill that in.
Oh. 58.
Yeah. And they give you the information in number 57, right? You see that? So you know the mean, you know the standard deviation, you can calculate the z-scores. That'll be it.
58. Okay.
Yeah. I love you guys. So yes, you can just do the homework you have to. But if you're smart, you're going to do a few more to get more practice. Or if you have time. I understand not having time, trust me. So anybody can ask anything from the book they want to. You guys just want to leave like really early. It's up to you. You're all ready for the test.
Yeah, right.
Do you really need the formula for
What, bro?
uniform distribution? Do we need the formula?
No.
What's up? Casey, what's up? Number 4. What about it? So that's exactly like those problems, to be honest. 4A is get the z-score, look it up. Like 4A number 1 is going to be 1 minus because, yeah, anytime you want an area up here, because the chart tells you the area below. Yeah. Yes?
Always need this for this, right? If you use this chart,
Yeah, totally. Yeah. You don't have to memorize all this. Oh, sure.
Once we do a whole section,
Just the ones you missed. See again? 4 to 7. Well, I mean 3 to 7. Yeah, you're right. If you haven't turned 3 in yet.
Can I get my test?
You what now? Yeah, go ahead.
I'm gonna study that anyway. Quick question. So I get pretty much all of this. The only thing I'm confused about is the bottom right here. I know it's kind of hard to ask, but so I know it's the z-score is 0 and the mean goes in the middle. But at what point am I using the actual numbers or the z-score? Does that make sense?
Not really.
Okay, so right
I mean,
here.
here I don't know the z-scores yet. I
Right.
put the numbers I know down, and underneath them in parentheses, that's what I do. That's where I put the z-scores. So I know I didn't do it every single time, but I did it a few times. Yeah, I did it here.
Okay.
Underneath I put the z-scores.
Okay.
Yeah, just keep myself straight.
Okay.
Yeah.
Good correction here.
Okay. Yep.
Question. So because this is off the chart, what would you say?
Yeah. So the z-score chart's kind of silly. It just says 0.0001, but that doesn't make any sense because if I went really far out, ain't that much. So I say if it's off the chart, I say it's about 0% or 100%. Depending on, you know, if it's probably X greater than this, it would be 100%. Less than this would be about 0%. Or the answer you said more 0 plus, like one little table we saw. Yeah. So about 0 or 0 plus, they both mean not really 0, but really close to 0. Sure.
I don't know.
Does it mean of that distribution? Of what distribution? I don't think it would make it.
So what, I'm sorry? You have an appointment to take it and you,
Yeah.
oh, and you can't make it? Okay, so you need to remind me so I can tell them, I can push it back to the end of this week maybe. Yeah, but I have to tell them it's okay to push it back to like Friday.
Do you want me to email you or something?
Yes, yes.
Sorry about that.
That's right. I mean, we'll work with it. Yeah.
I'm having like a hard time catching up on the homework and all that because I'm trying to do it current.
I'm with you. I understand that.
Thank you.
Sure.
Corrections.